Problem number 6 of the 2018 free response, and problem number 6 is a no calculator question. And right out of the gate you can see that we are given a differential equation, and the differential equation is in terms of x and y. A slope field, part A, for the given differential equation is shown below. So in a minute I'll reveal the slope field. Sketch the solution curve that passes through the point 0, 2. So we're going to draw a solution curve through 0, 2, and then we're going to draw a solution curve through 1, 0. Remember that there are three things that the reader will look for when you are drawing a solution curve. The first thing is that you must go through the point. So you're going to have to go through 0, 2, and you're going to have to go through 1, 0. The second thing that we look for is the correct shape, meaning that you must follow the slope field. And the third thing that we look for is to fill the field as far as it will allow you to go. And we've recently talked about that in class. So let me show you my curves. So let's begin with the point 0, 2. The point 0, 2 is right here, right there. And the point 0, 2, the slope field guides me through a horizontal line. And so that's what I'm going to sketch for the solution curve at 0, 2. For the point 1, 0, the point 1, 0 is right here. And so for the point 1, 0, I'm going to follow the slope field. And the slope field guides me into the shape that I have here. And but just to be safe, I'd probably make that just a tad longer over here, and I'm good on the other side. And we'll look at the scoring guide after we look at all of my solutions. Letter B. Let f of x be the particular solution, so they're not asking us to find the particular solution yet, to the given differential equation with an initial condition 1, 0. So we have the point 1, 0, and that's going to help us to find the value of c if we have to solve the differential equation, but in this case I don't think that we do. All they want us to do is write the equation of a tangent line. So we're going to do y minus y1. We have our x value of, we have our x value of 1 and our y value of 0, and we're going to need our slope. So we're going to take the x and y value of 1, 0, and we're going to go all the way back up to the differential equation, substitute in order to get the slope. Secondly, second thing that they want us to do is to use our tangent line to approximate the y value at 0.7. So let's take a look at my work for part B. So notice I start out with the equation of a line, which is what we always do when we're asked to write the equation of a line. Over here is me finding the derivative so I can get the slope of my tangent line. So I substitute 1 in place of x and 0 in place of y. And I'm going to simplify that to be 4/3. And so that is going to be the slope of my tangent line, which goes right there. And then my y value is 0, my x value is 1, and then I don't need the 0, so I get y equal to 4/3 x minus 1. And then they want me to use the equation of that tangent line to approximate the y value at 0.7. So y of 0.7, all I'm going to do is substitute 0.7 in place of my x and my tangent line, and I am not going to simplify. This will get full credit. I do not have to subtract. I do not have to multiply by 4/3. And so if I can convince you of anything, I want to convince you of leaving your answer unsimplified. And in part C, they finally tell us to find the particular solution. So we're going to solve the differential equation, separate, integrate, solve, and we have the same initial condition of f of 1 equal to 0. So first thing we're looking for is a good separation. Let's go back up to the differential equation. I am going to divide the y term, the y minus 2 squared, to the left side and move the dx to the right side. So I have a good separation, so I assure you I'm going to get 1 point for that. And then I'm going to integrate on both sides. So this is my separation, this is my integration. And in that case, I moved the y minus 2 to the numerator and gave it a negative power. I can do a u sub. I can let u equal to y minus 2, but when I take the derivative of y minus 2, I'm just going to get 1, so I don't really need that u substitution. I don't have to compensate for anything. So when I integrate on the left side, I'm going to increase the power by 1 to negative 1. I'm going to divide by the new power of negative 1. On the right side, notice I just pulled my 1/3 coefficient off, and I did the power rule, increase the power by 1 and divide by the power. The next thing I'm going to do is I'm going to take the negative power down to the denominator, so the numerator is left with a negative 1. I took the y minus 2 to the denominator and gave it a positive 1 power. I multiplied 3 times 2 to get the 6, which is where that came from. And now I'm going to stop and I'm going to substitute the initial condition to find the value of c. So I'm substituting the x value of 1, and I'm substituting the y value of 0. And then I get 1/2 on the left-hand side, I get 1/6 on the right-hand side, subtract 1/6 from both sides, and I get c equal to 1/3. Now remember that 1/3 has to get substituted back right where I left off, and I left off right back here. So I'm going to substitute where I left off, which is right here. I substitute the value of c. I'm leaving the left-hand side alone, and on the right-hand side I'm getting a common denominator of 6, so I can take these two fractions and make one fraction. And as we've discussed in class, if we have one fraction equal to one fraction, we can take the reciprocal of both sides, and those reciprocals are equal to each other. So that's what I'm doing right here, taking the reciprocal of both sides. And that will allow me, remember I'm trying to get y by itself, so I can multiply both sides by -1, so that's what I did to get the -6. And then I can add 2 to both sides. I don't have to get a common denominator. I can leave my answer, just like that. And now let's look at the scoring guide, and you can try and score yourself. So there is 1 point for the solution curve through 0, 2, and there's 1 point for the solution curve 1, 0, and I talked about the criteria that have to be fulfilled in order to get those points. All right, so let's look at the next part. So for part B, we were writing the equation of the tangent line. You get 1 point for totally getting the equation of the tangent line correct. And then you're going to get 1 point for your approximation. You can see over here in the scoring guide that they simplify all the way to -0.4. Please, please, please do not simplify. This will get you full credit. It's really dangerous to do that simplification, because if you make one calculation error, notice this is only worth 1 point. So if you make a calculation error, you're totally done. Don't simplify. For part C, in class we've talked about how that's generally scored. There's 1 point for the separation of the variables. So if you have a good separation, like you can see here, then you're going to get that first point. The second point is for getting both antiderivatives correct. I think sometimes this is a split point, but not as easy as this is, and I don't have the scoring notes on this one, so I can't promise you exactly how it's scored. But I think you're probably going to have to get both antiderivatives in order to get that second point, or to get those 2 points, I'm sorry. The third point is the constant of integration and using the initial condition, so we're going to have a plus c, and you're substituting the 0, 1 for the third point, or was it 1, 0? I think it's 1, 0. And then solving for y, you have to have completely the correct answer. Y has to be by itself with no errors to get that last point. Notice If the student does not show a separation, there will be 0 points awarded for any other parts of the problem. There are a maximum 3 out of 5 points if there's no constant of integration. So make sure you pay attention to those small things that make a big difference.